On the bench today is this realistic SA-100B solid-state stereo amplifier. It's their entry-level model. Over the years they made different versions of this, and they had a couple at the same time, and this was the entry-level one. This is the most basic. I had a friend give this to me. I was up in Michigan visiting a friend this week, and he offered it to me for free. He said it works, but it's been sitting out in his barn, so I don't know when it has last been used. It's in very good shape. It is quite dirty. It needs cleaned up, but it's in pretty good shape cosmetically. When you lift this thing up, it's heavy. It feels like it weighs 5 pounds. The top, bottom, and back plates are all steel. This is extruded aluminum front, wood veneer on the side. It's not vinyl veneer. And let's take a look at the front panel here. Just your basic controls: volume, balance, and tone. Speakers on and off. It has just 2 inputs. Well, this is the mode here, but it has a phono, which is ceramic only, and a tuner, and has stereo mono and power on and off, indicator light, and the old Radio Shack sign. I checked online at RadioShackCatalogs.com, and this model was available in the 1970 through 72 catalog. Now, the way they publish their catalogs, they came out usually in the late summer of the previous year. So this would have been offered from 1969 until whenever they stopped carrying it, probably through 1972. When they started offering the new one. Now, they had the exact same amplifier, but it was cosmetically different. It had a different looking front in the 1969 catalog. But they called it the SA-100, no B suffix. So this is really, I believe it's just a cosmetic upgrade. Without seeing a schematic or anything, I can't tell you, but it looks exactly the same except for the cosmetics. Same switches and controls and everything. So the design is probably late 60s. It was probably designed in 1967. So it'd be very interesting when I pop the top of this thing. Take a look inside. Might even see interstage coupling transformers. They did some weird stuff with solid state back in those days. Just speaker terminals and your phono and tuner. That's all you get. So it's a very basic amplifier. Nothing on the bottom. Well, we just got this information on the bottom. Pretty dirty. I don't think that's, no, it's not rust, it's just dirt. That's a steel plate. Sticks to a magnet. Okay, so the first order of business is to hook this thing up and see if it works. It was advertised as a 10-watt amplifier. Probably something like 5 watts per channel, and I'm going to say that's probably very optimistic. They really didn't have a good standard on rating power, advertising power ratings, I should say, back in those days. But if it's working fine, we'll do a power test and all that good stuff. Okay, let me get the thing hooked up and we'll go from there. Okay, it's plugged in and I can hear a faint hum from the transformer. I hooked up a music player and some speakers. And I've never turned it on before, so here goes. Well, the little light came on. Looks like an LED, but I assure you that is an incandescent bulb. Let me put my ear. Yeah, I didn't hear a click. I didn't hear any sound from this thing. Let me turn the music player on, see if it's going to output any sound. Okay, I'll just hit the button here and go, and turn the volume up to a decent level. Oh, you know what? Speakers are set for off. Duh. Okay, I can hear sound. I'm not sure what selector. Let's see here. Still nothing. Let's see, we'll try it. Okay, I can't play that music. That is not YouTube safe. Okay, we'll try this. Doing some weird. Listen to that. It's not doing it now, but it's like might be oscillating or something. A lot of noise too. I don't know if you can hear that or not. It's got a preamp stage because the volume control diminishes the noise when I turn it down. The hiss, it's actually a hiss, so there's a upfront stage doing that. So it kind of works, but it does have issues. I'm going to pop the top and take a look inside. And we're in. And yeah, this is an old design. Like I said, probably designed in 1967, because it would have had to been in the 69 catalog, which they would have had to get prepared in 68. You can see the interstage coupling transformers. Wasn't sure if they would have them or not, but they certainly are in there. They have these metal can type transistors. Those are actually pretty good. It's a shame they don't make them as much as they used to. I like how they mounted these driver transistors to the transformers. There's a little clip on the side there. This is the outputs here, and they used the metal cans again. Toshiba transistors, and that's a Hitachi symbol there. I can see that on a lot of the capacitors, Hitachi. So this thing was probably made in Japan. Have to see if it, I'm not sure if it said it in the catalog or not, but likely made in Japan. I removed this little clamp piece holding the output transistors down, and they are all the same type, 2SB415, 32 volt 1 amp germanium transistors. And these drivers are 2SB56 and the preamp stages are 2SB440, and they're all germanium. So this is an entirely germanium based amplifier, and I bet if I put a meter on the power supply filter cap, we should find this is probably a positive ground. Let's see here if I can get this. I don't know if I can get the meter in the shot or not. And of course, there's a big glare on the screen. Okay. Of course, the thing's going to be all tangled. Okay, so I'll go from the output grounds to the positive of the supply cap. Move my hand out of the way there. Okay, so if I go from the output grounds here, right here's I got the probe to the positive of the capacitor. Yep, showing 0, so it is a positive ground amp. See, if I go from the negative side of the supply cap, you'll just get changing numbers as the capacitor charge changes from the meter voltage. But yeah, it's a positive ground germanium type amplifier. I found out that distortion is not from the amplifier. So watch this. I'll turn the music player on. I have this thing set for mono. Now listen to the distortion. Hear that kind of scratchy, hissy noise? Now if I turn this back to stereo and play it, doesn't do it anymore. Well, here is the problem. It's coming from the music player. What this amplifier does, let me turn it off here. What it does is short circuit the two channels together to make a mono, and the music player does not like its output to be shorted. So if I go across, let's see if I can put my are we in, oh, I gotta set it, gotta put it in mono. Look at that, 0.5 ohms. It's shorting it together. And of course when it's in stereo, let me put that on there again, and it's probably measuring my I gotta hold my hand over it, so it's very high impedance there. So it's looking better for this amplifier being okay. However, I did find some more problems. I noticed when I turned the power off, one channel would die out quicker. And when I turned the power on, it would come on instantly and the other channel would be delayed. Another thing I found out, one of the channels has less bass. The bass seems to be weak. So I'm kind of thinking this thing might have drying up capacitors in it. Let me see if I can locate a schematic. That would help immensely with this thing. Okay, I found a schematic fairly easily. You know, the catalog price of this amp was $35. And they probably sold a ton of them. And that makes the chances for needing repair a lot higher. So yeah, it wasn't too difficult to find a schematic. One issue with these older amps is they used electrolytic capacitors all over the place. I mean, look at this. Electrolytics here and then a bunch of them scattered throughout the circuit. So that'll make repairing this thing more difficult because there's more to look through. But instead of just blindly replacing caps all over the place, you know, it's better to diagnose the problem and attack it at that point. I mean, you can still replace all the caps, and I probably would recommend that. But to be certain, I would try to find the source of the problem. So I'm going to get to work on this thing and see if I can localize the problem. Like I said in my other repair videos, you can pick signals off from and inject signals into certain parts of the amplifier and see where the problem actually starts by analyzing the results you get. Listen to how distorted the bass is on the left channel. Now I'll move over to the right by panning the balance control. So there is definitely something going on with the left channel here, for one thing. So I need to tackle that, see what the problem is. Okay, I'm going to test the output stages. We're going to inject a signal right at the base of this driver transistor, and I'll try both channels. And this is where my little preamp comes in handy. This thing just doesn't have the gusto to do it. Not enough voltage output swing or current. So I'm feeding a 50 Hertz signal in to the preamp, and I have a capacitor. You always want to use a capacitor, or you can throw off the bias. So let me set the camera down so where you can see it. So let's see, where is it? I don't know if you can see it, but the base is right here. I don't know if the camera picks that up or not, but it sounds okay. And I'll probably put a load and use the scope as well to check. Okay, the base over here. Okay, that line is the base. That seems okay as well. Another thing is I can put signals into the preamp and pick that signal off at the exact same point by using the same capacitor technique, but sending it into an amplifier and analyzing what the signal looks like, or just using the oscilloscope. Okay, I'm injecting the signal. The thing puts out a little over 3 volts before clipping into an 8 ohm load. I switched over to my resistors here using the scope. Injecting the signal into the output stage, like I mentioned before, right at the base of the driver. Yeah, this thing is not a real powerful amp because 3 volts into 8 ohm loads is a little over a watt. That's not even both channels driven, so it'll sag even more when we have the power supply loaded down with both channels. But I checked at 1K and 100 Hertz, and they seem about the same. Bass is kind of weak because they use these 470 microfarads. It says 500 on the sheet, but it's actually 470. I would upgrade those to 1000. I wouldn't go beyond that, because if you power up the amp and that capacitor's discharge, it's going to send a blast of current through that to charge it up. And those output transistors are not the most powerful around, and it could potentially damage them. So I would go with 1000 microfarad maximum on this thing. But that's one upgrade I would recommend for sure. Okay, so now I'm going to extract the signal now that the output stage seems to be in good health. So now I'm extracting the signal from that same point. So now I have the music player feeding into the amplifier. Make sure I have the tone control centered, and use the volume control. So I'll flip that around and I'll extract the signal at the base of the driver and look at it on the scope, and then that'll allow us to see what this input stage is doing, this preamp part. Okay, so I have the balance has got to be centered. Okay, we got everything set up. Okay, this is the right channel. Yeah, that'd be the right channel. And that's the volume control. It's clipping pretty early. That doesn't necessarily mean anything's wrong. Let's see. Let me find where the output stage clips. We're clearly... turn that down. Okay, we're clipping here. Let me go back to the preamp. You definitely don't want your output stage clipping. So we're getting a clean signal in from the preamp. So we have to turn it up quite a ways before starting to clip. So that preamp stage would not be causing any issues. So I'll set this level right to where this side begins to clip. And now let's take a look at what's coming out of the left channel. Oh boy, that's bad already. It's flat topping the top now. See it? Let's turn that down. Yeah, this is not good at all. Let's see what's coming out of the output of that. Okay, this is the amplifier's output with the 8 ohm load. Yeah, it's just bringing that signal to the output. It's flat topping it. That's why we were getting that horrible distorted bass, because the input is because the preamp is feeding a nasty signal to the output stage. So we have to check and see what's going on with that preamp stage. Now, can you see the power of signal injection and signal extraction? It's excellent to help you locate the problem. Okay, looking around the circuit, doing some measurements. Pretty sure this is the left channel. The way they drew these switches, you have the left coming in on this side, which comes down here to volume potentiometer and into the amplifier, so I'm pretty sure that's the left. I found something weird already. R12 is spec'd out to be 3.3K, and it's going to be the same. And it's bypassed with a 33. This says 30, but it's a 33. Sometimes schematics don't match. However, R12 here is a 4.7K. But it's 3.3K here. And it doesn't look like this amp's ever been monkeyed with. You can see the traces. The light comes through the board, you can see the traces. And this is the input cap. And it's hard to see, but it goes into this transistor. And here's the cap that's in question. And there's two lines that go to this 33 microfarad cap. And this is the 330 ohm, orange, black. Now this is the emitter circuit, 33 ohm, and our 3.3K bypass with the 33. But that is a 4.7K. Let me see if the light will show that. Yeah, you probably can't see it. That's an orange, purple, red. That's a 4.7K. That was put in wrong at the factory. I don't see any evidence that this thing's been worked on. But whoever bought this amp probably didn't really play real bassy music or crank it up loud enough to notice. Or, you know, the other channel covered the distortion. Well, I'm going to switch that out first thing. You have to remember, these things were hand assembled back in the day. And I think somebody just popped in a 4.7. I did check the other channel, and it has a 3.3K. There's no 4.7s used in this preamp anywhere. Okay, let's see what we have. Oh, there's Snickers. Loving my power supply there. Oh, uh-oh. Cat coming down. Warning, cat coming down. Probably gonna step on and kick stuff. Always going in front of the scope. Oh, don't step on the amp. There he goes. Okay. The cat is out of the way. And let's see here. Output of the good channel. Again. That's the output. Almost 2 volts. It starts flattening on the bottom. And here is the bad side. Snickers. Here's the bad side, and it is now good. It starts clipping on the top, but let's check the output. As long as the output is well into clipping before the preamp. Yeah, see, the output is well into clipping. We can tune that out and go back to the output of the preamp stage. Yeah, that's clipping, or I mean, that is not clipping at all. You have to tune it way up before it starts to clip. So this thing is working now. That's just unbelievable. I've never seen that before. They got the wrong part put in. Now I've seen where they've changed part specifications and not updated the data sheet or the schematic, but they would change the parts for all channels involved. But in this case, it was obviously a mistaken part, and like I said, the part was not, or the amp did not look to be monkeyed with before. There's the new resistor, a 1/4 watt. Well, let's hook it up and test it again. Okay, well, fail.
Continue to cut them down, whether it's for housing, farming, alternative energy, or just useless furniture. Instead of constantly getting together and fighting for something, fighting against global warming.
Bass is still really distorted out of the left channel. Well, I thought that would fix it. That was clearly a fix for that preamp issue. You saw how much better the waveform was. But we have some other issue with bass. So I'm going to put a lower frequency signal into this thing and see what we're getting out. Okay, I'm playing a 45 Hertz tone. It's obviously quite distorted. And this is what's going in from the preamp. It looks clean to me. And here's the other side that we just fixed. That also looks clean. So the preamp is not the problem in this case. Let's turn the just that there. This is the output of the good channel, the output of the bad channel. Now they're both clipping. Let me turn the volume. Oh, hang on. Okay, sorry about that. The battery quit my camera. I bought this battery off of eBay so I'd have a second battery for my camera, and it doesn't last that long. Typical crap you get on eBay. Okay, so I tuned this out of clipping. And here is the bad channel. It still has some distortion in it. I think you're seeing the slope of the capacitor. You have to remember these are 470 microfarad output coupling caps. Let me find the input side. Okay, that's better. We'll just skip the cap because it's going to give you a weird looking signal. Okay, and this is the good channel side. So that looks clean. And the bad channel is clipping on the top early. That'll clean up if I tune it out. So I have to backtrack through the circuit and see where we're getting this distortion from. Problem is this has negative feedback, so distortion will be carried around. Okay, I got it fixed. Changed the output capacitors and the emitter resistor bypass. Let's see here. This is the bad channel, which is working now. 1.87 volts. The other channel 1.9. Yeah, pretty close. And the input is actually not quite even because, you know, these potentiometers have a slight variance in them, so that's why you see a bit of difference in the output. But no more distortion. It's looking good. So what I did was, with no signal, I checked all the DC measurements between the channels. This schematic doesn't provide any, but I just went ahead and measured and compared them, and everything was matching perfectly between the channels. So there's only capacitors which would affect the AC operation, especially at low frequency. And these output capacitors were pretty pooched, so I replaced them. The old ones were measuring 260 microfarads, so I replaced them with 1000 microfarads. It could go even higher for even lower bass, but I wouldn't really recommend it. It's starting to roll off anyway, probably because of the response of the transformer. And I don't know if I said it, the output stage didn't have any lytics in it besides that, but there was one bypassing this emitter resistor, and these seem to be the main culprit. Once I changed that, the amp is now pretty even in both channels at low frequencies, and there's no more distortion. Plus the larger value outputs will give us a little bit better bass. Okay, no more bass distortion. very good. Now I'll do a power test, clean it up, and call it a day. Would I change all the other capacitors? Absolutely. I don't have enough right now, but I would go ahead and change the rest of them. There's been enough of them shown to be bad that I would change. I'm not one of those types that just say, oh, go ahead and replace all the caps, but you know, this thing's about 50 years old, so yeah, in this case I probably would. Okay, power test time. Both channels driven, 8 ohm loads, 3.3 volts it looks like. 3.3 squared divided by 8. 1.36 watts of output. So that is, it's not a real powerful amp to be sure. Let's turn that off and look at distortion. Well, here's my built-in 4.5 kilohertz pilot signal. And this amp has a second order and a third order harmonic that's fairly high. I mean, this here is 1%, the pilot signal. So, you know, this one is, these are around 3% each. So, to say this amp would have a sound character all its own, I would agree. Some people say that the low order harmonics are not really harmful to the sound, though I prefer an amplifier be true to the sound and not really have any audible characteristics or distortion. But this amp will have it. Of course, we're right up against clipping. If we turn that down, you know, those will diminish quite a bit. And here's our pilot signal, and our second order harmonic is probably less than 2%. Third order is really low, but yeah, there's clipping. So yeah, it might kind of soft clip a little bit, meaning as you approach clipping, you kind of flatten the top of the waveform and you get those harmonics. That could be it too, just the design of these old amplifiers. Here's a quick review of the parts I changed. The two output capacitors. One's looking a little bloated on the bottom. And the emitter, resistor, and the driver stage. Different caps. I'm kind of wondering if somebody's been in that thing. It doesn't look like it's ever been worked on. And in the preamp stage, the incorrect value causing that weird bias issue, which I guess there wasn't enough signal to cause a lot of distortion in the output with that, but it was looking pretty bad though, so I went ahead and put the correct value in, and that really fixed it up. Okay, it's all assembled. I cleaned the case up. It does say made in Japan down in the corner there. Japan. So yep, that confirms that. So that is a nice little amplifier. Not real powerful, but an old classic that should live on. Well, that's it. Thanks for watching.